Hello students, welcome you all back to our lectures on normal distribution. So presently we are doing the problems on normal distribution. We have already completed binomial and Poisson. Hope you have watched the discrete probability distribution of Poisson and binomial. Now normal distribution, last video I have discussed about the theory of normal distribution. What is normal distribution? It's a continuous probability distribution which is applied in those cases where the random variable will take any value, whole number or fraction, right? So normal distribution, it will be represented by a normal curve which is a bell-shaped curve. It is symmetrical on both the sides to the perpendicular of the curve. And we have done 4 problems on this normal distribution. Now we'll start the 5th problem. Hope everybody have got the hard copy of the problems, print out of the problems from the link under my description. So if you have not, please take a printout of the problems, then only you can be able to understand the problem and the explanation. Come on, now we'll start the problem number 5. Now see, a normal distribution has 77 as mean. Find its standard deviation if 20% of the area under the normal curve lies to the right of 90. We have to find out what is the standard deviation. Mean value is given 77 and it is given that 20% of the values are over 90. Over 90. That's it. Now see carefully. Mu is equal to 77 given in the problem. Standard deviation we have to find out. 20% of the area under the normal curve lies to the right of 90. First of all, we'll draw the normal curve. It's symmetrical, bell-shaped curve. Now, perpendicular we'll draw from the middle of the curve so that exactly equal area lies to the left and the right of the curve, right? 0.5 area on left side, 0.5 area on the right side. The total area is 1 under the normal curve. Now, in the middle, the mean. The mean is given as 77, so we take mu is equal to 77, z is equal to 0, always in the middle. Now, when given 20% of the area under the normal curve lies to the right of 90, first of all compare this 90 with the mean. Mean 77, 90 is greater than 77, that's why I have taken 90 here, x is equal to 90. Z is equal to how much we have to find out. So 90, it is given that 20% of the values are over 90, above 90, the right side. This shaded area you can see now, this shaded area is over 90. And this shaded area is given in the problem 20%. 20% means 0.2. The 0.2 is this shaded area. Then what is the unshaded area here? The total area from the middle is 0.5. From the middle to extreme, continuously right side, it is 0.5. So 0.5 minus 0.2, you will get 0.3. Unshaded area is 0.3. Now, by using this area of 0.3, we are going to find out what is the value of Z. Previous theory video, I told you, there is an area table called normal distribution area table. In this table, you can see on left hand side Z values and the top right Z values, and the body of the table will give you the area. Now we are having the area of 0.3 and we need Z value. So in this body of this area table, you have to locate where is 0.3. You won't get exactly 0.3 because 4 digits are given. After decimal, 4 digits are given. So you find the nearest value to 0.3. Nearest value to 0.3. So if you find, you will get 0.8 under 4. The left hand side Z value against 0.8 under 4. Against 0.8, this is 0.8 under 4. You will get 0.2995. 0.2995. You are getting this value in the row 0.8, column 4. 0.8 के रो में और column 4 में you will find the value 0.2995. And that value is very nearest to 0.3. That value is nearest to 0.3. So we can take Z value 0.84. So here you can write Z is equal to 0.84. So by using this area, we have found the value of Z. Now we apply the standard normal variate equation. The standard normal variate equation is Z is equal to x minus mu by sigma. Already in the previous problem also we have applied. This is the value to find out the Z value. But here Z value already we got 0.84. X value is given 90 and mu is 77. Sigma we don't have. So in whole the equation only one unknown variable is there, that is standard deviation. Now cross multiply. We'll make a cross multiply. So it will become 0.84 sigma is equal to 13 into 1 13. So 0.84 sigma is equal to 13. Sigma is equal to 13 by 0.84. You'll get 15.48. Standard deviation is 15.48. That's all. So you know how to calculate the standard deviation by using this area, by using normal distribution. Now we'll come to the next problem, sixth one. Now see the sixth one. For a normal distribution with mean 50 and standard deviation 15, find Q1 and Q3. Q1 stands for lower quartile and Q3 stands for upper quartile. So from this given data, in a normal distribution, mean is given, standard deviation is given, we have to find out the two quartiles. How to find out? I'll explain you. Mean mu is equal to 50, standard deviation sigma 15, Q1 how much, Q2 how much. According to normal distribution, mean is equal to median is equal to mode. Previous theory video I explained you that in a normal distribution all the three averages will be equal. Mean, median, mode. So when all the three are equal, so we can take mean is equal to median. जब mean 50 है तो median भी 50 रहेगा, right? The quartiles are equidistant from median. Now see here, in a normal distribution, in a normal curve, the center is exactly median because mean, median, mode all are equal. So in the center perpendicular line, you will have mean, median, mode same. Now the quartiles are exactly equidistant from the median. अगर मीडियन से Q1 को जाएंगे या मीडियन से Q3 को जाएंगे, the area from median to Q1 will be exactly equal to median to Q3. Equidistant. The quartiles are completely equidistant from the median. So median minus Q1. If you subtract median minus Q1, then it will be exactly equal to Q3 minus median. The area from median to Q1 and median to Q3 is exactly equal. So we can write median minus Q1 is exactly equal to Q3 minus median. Median we got already 50. So in place of median I am writing 50 minus Q1 is equal to Q3 we don't have. Median is 50. Now see here on LHS and RHS, one variable is there, one constant is there. So bring the constant at one side, variables at other side. So this one 50. Bring this right hand side RHS minus 50 to LHS. So minus 50 will become plus 50. Take this minus Q1 to RHS. Minus Q1 will become plus Q1. So 50 plus 50, 100. So Q3 plus Q1 is equal to 100. One equation we got it. From this explanation, we got one equation called Q3 plus Q1 is equal to 100. Now according to normal distribution, semi-interquartile range is equal to 0.6745 sigma. That is one of the property in normal distribution. One of the property in normal distribution is semi-interquartile range is equal to 0.6745 standard deviation. Now what is the formula for semi-interquartile range? Already in statistics, measures of central tendency, we have seen that semi-interquartile range formula is Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. This is the formula for semi-interquartile range is equal to 0.6745. If we make a cross multiplication here, take this 2 to RHS, so it will become multiplication. Here division is there, so it will be multiplication. So Q3 plus Q1 is equal to 2 into 0.6745 into standard deviation. Standard deviation is 15. Now if you multiply the three constants, you will get 20.235. So we got second equation, Q3 minus Q1 is equal to 20.235. So two equations we can be able to form. The first equation Q3 plus Q1 100, Q3 minus Q1 20.235. Now solving these two equations, Q3 plus Q1 100, Q3 minus Q1 20.235. Plus Q1 minus Q1 will get cancelled. So Q3 plus Q3, 2Q3 is equal to 100 plus 20, 120.235. So Q3 is equal to 120.235 divided by 2, 60.1175. So we got the third quartile, upper quartile. Q3 value 20.1175. So we got one value. Now substituting the value of Q3 in equation 1. In equation 1, Q3 plus Q1 is equal to 100. So in place of Q3, I am writing 60.1175 plus Q1 is equal to 100. Now take this 60 to RHS. So it will become minus. So 100 minus 60, 39.8825. So ultimate finally Q1 we got, Q3 we got 39.8825, 60.117. That's what it is asking you to calculate. It's completely clear. So you have to remember these properties of normal distribution. The first property you remember, in a normal distribution, mean, median, mode are all equal. So when mean is 50, median will also be 50. Second property you remember, the quartiles are completely equidistant from the median. मीडियन से Q1 को और मीडियन से Q3 को exactly equal size रहता है. तो the difference between median and Q3 and median and Q1 it will be same. So Q3 median minus Q1 is equal to Q3 minus median. ये प्रॉपर्टी को यूज करके एक इक्वेशन. एंड सेकंड वन मोर प्रॉपर्टी यू रिमेंबर, सेमी इंटरक्वार्टाइल रेंज is equal to 0.6745 into standard deviation. And the formula for semi interquartile range is Q3 minus Q1 by 2. By using this we got another equation. Solving the two equations we can get the value of Q1 and Q3. That's it. So we have completed sixth problem. Now students see the next problem, seventh problem. The mean and standard deviation of a normal distribution are 60 and 5. Mean is 60, standard deviation is 5. Find the interquartile range. See here, semi interquartile range का मतलब होता है, see here, semi interquartile range means Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. This is semi interquartile range. If you want only quartile range, interquartile range, then don't divide it by 2. Only Q3 minus Q1. Q3 minus Q1 is called interquartile range. That's what we have to find out. Now, mean is equal to 60, standard deviation is equal to 5. Interquartile range is Q3 minus Q1. Semi interquartile range का मतलब यहाँ पर divide by 2 कर देना. अगर only interquartile range, Q3 minus Q1, this we have to find out. So according to normal distribution, mean, median, mode all are equal. So when mean is 60, median will also be 60. The quartiles are equidistant from median. Just now I have discussed in detail. So median minus Q1 is equal to Q3 minus median. Median is 60. So 60 minus Q1 is equal to Q3 minus 60. Now take the constant at one side and variable at other side. 60, bring the 60 to LHS plus 60 and take this Q1 to RHS plus Q1. So Q3 plus Q1 is equal to 120. First equation we got. Now according to normal distribution, semi interquartile range is equal to 0.6745 standard deviation. Just like the previous problem. So semi interquartile range formula, Q3 minus Q1 divided by 2 is equal to Q3 is equal to 0.6745 into standard deviation. So Q3 minus Q1 is equal to 2. Cross multiply करेंगे तो 2 into 0.6745 divided by 3. Here itself we got Q3 minus Q1 is equal to 6745. Here itself our answer is over. But for your practice, I am explaining how to calculate Q1 and Q3. Problem it is asking you interquartile range. So interquartile range is Q3 minus Q1. We got it Q3 minus Q1, 6.745. Our answer is over. But for your practice individually to calculate both, solving the two equations, Q3 plus Q1 is 120 here and Q3 minus Q1 6.745. Then plus Q1 minus Q1 get cancelled. 2Q3 is equal to this much. Q3 is equal to 63.37. One value we got Q3. Substituting the value of Q3 in equation 1, Q3 plus Q1 is equal to 120. We got Q1. When we got Q3 and Q1, we can calculate interquartile range. Otherwise, only for your practice I am explaining this. Otherwise, our answer is ended here itself. This is the end of problem number 7. Now we'll start the next problem, problem number 8. See the 8th problem. Suppose that sizes of hats are approximately normally distributed with a mean of 18.5 centimeter and standard deviation of 2.5 centimeter. So we are having the size of hats between the mean of which is 18.5 and standard deviation 2.5. How many hats in a total of 2000 will have sizes between 18 centimeter to 20 centimeter? That is the first question. Second question is more than 20 centimeter. So two questions are asked. Total number of hats are 2000. Out of 2000, how many hats are expected to have a size between 18 and 20? 18 and 20. यानी 2000 hats में कितने hats ऐसे हो सकते हैं जिसका size 18 से 20 के बीच में हो? And second question is more than 20 centimeter. How many hats are expected to have a size of more than 20 centimeter? Area between t is equal to 0 and t is equal to 0.6 is 0.2257. The area value is directly given in the problem. Instead of z, it is saying t. Doesn't matter whether it is t or z. So when z is equal to 0 to z is equal to 0.6 is 0.2257, and area between z is equal to 0 and z is equal to 0.2 is 0.0793, where t is the standard normal variant. We call it as z. That's it. So first of all, you understood the contents of the problem. The mean mu is 18.5 centimeter. On an average, the size of the hat is 18.5 centimeter, and the standard deviation is 2.5. Now we'll attempt the first question. Number of hats that in a total of 2000 that will have a sizes between 18 centimeter and 20 centimeter. यानी पूरे 2000 हैट में कितने हैट ऐसे एक्सपेक्टेड हैं जिसके साइज 18 से 20 के बीच में हो? That is the question, right? Now, when x is equal to 18, first of all we'll take 18. When x is equal to 18, the standard normal variate. The standard normal variate formula is z is equal to x minus mu by sigma. X how much here? 18. Mu is how much? 18.5. Sigma is 2.5. If you solve, you are getting minus 0.2. Z is equal to minus 0.2. When we are getting? When x is equal to 18. Similarly, when x is equal to 20. When x is equal to 20, what is the value of z? So z is equal to 20 minus 18.5 divided by 2.5, you are getting 0.6. Right? When x is equal to 20, z is 0.6. When x is equal to 18, z is minus 0.2. Now we'll represent the given information in the normal curve. We'll draw the normal curve. The central perpendicular is mu, that is 18.5. This is 18. And z is equal to 0. Now, the two values, x values are 18 and 20. See here, 18 is less than mu and 20 is more than mu. Mu is 18.5. अब एक value 18 है, दूसरा value 20 है. तो 18 will be taken on left hand side and 20 will be taken on the right hand side. Right? Now, so when x is equal to 18, z is minus 0.2, already we have calculated. When x is equal to 20, z is equal to 0.6, we have calculated. Now we need the area from x is equal to 18 to x is equal to 20. From here to here, the shaded area, this is the area we require, right? Now, area from z is equal to 0 to z is equal to 0.2. See here, 0.2. The z value may be negative or positive, doesn't matter, the area will always be positive. The area will always be positive. So z is equal to 0 to z is equal to 0.2. If you refer the area table, from z is equal to 0 to z is equal to 0.2, or else it is given in the problem itself. Problem में ही दे दिया z is equal to 0 to z is equal to 0.2. The value is 0.0793. तो यहां से यहां तक का एरिया 0.0793. Similarly, area from z is equal to 0 to z is equal to 0.6 is 0.2257. So this area from z is equal to 0 to z is equal to 0.6 is 0.2257. So both the area we got left hand side and right hand side, we need the total area. ये total area रहेगा between x is equal to 18 to x is equal to 20. So here, therefore, total area between x is equal to 18 to x is equal to 20 is 0.0793 plus 0.2257. दोनों को add कर लो, you will get 0.305. 0.305 is the total area. Now we have to calculate how many hats are expected. How many hats are expected in a total of 2000. Total number of hats are 2000. 2000 में कितने hats ऐसे हैं जो ये size के बीच में आएंगे, 18 और 20 के बीच में आएंगे. So total number of hats between the size 18 to 20 centimeter is 0.305 into 2610 hats. So out of a total of 2000, we expect 610 hats are those hats which have the sizes between 18 to 20 centimeter. That's all. This is the first question completed. Now second part is number of hats that have a size of more than 20 centimeter. Above 20 centimeter, right? When x is equal to 20, z का value कितना है? X minus mu by sigma 20 minus 18.5 divide by 2.5. I'm substituting, we got 0.6. So when x is equal to 20, z is equal to 0.6. Now we need the area more than 20 centimeter, more than 20. So right side of x is equal to 20. First of all, we'll draw the normal curve. Middle mean 18.5. Now 20 is greater than 18.5. That's why I've taken on the right hand side. So x is equal to 20, z is equal to 0.6. Now we need the area for more than 20. So this is the shaded area we require. More than 20. Right? This is the area. Area from z is equal to 0 to z is equal to 0.6. From here to here, unshaded area is 0.2257. In the problem, it is given the value of the area for a value z is equal to 0 to z is equal to 0.6. It is given in the problem 0.2257. So ये unshaded area आ गया 0.2257, but we don't require unshaded. We don't shaded area. We want this shaded area. We know the total area under normal curve is 1.5 area left hand side, 0.5 area right hand side. So from middle perpendicular to the complete right hand side, complete area 0.5 है. 0.5 में unshaded area 0.2257 है. तो shaded area कितना होगा? 0.5 minus 0.2257, you get 0.2743. So this shaded area is 0.2743. Area for x greater than 20 is 0.5 minus 0.2257, 0.2743. Now number of hats having a size of more than 20 centimeters is 2000 into 0.2743, 549 hats. So we expect 549 hats, the sizes of which are more than 20 centimeter. That's all. This is the problem number 8. Now we discuss the problem number 9. See here. The mean weight of 500 male students of a certain college is 65.5 kilogram and the standard deviation is 10 kilogram. So we are calculating the weight of college students. So 500 male students, we have checked the average. The average weight of student is 65.5 kilogram. The standard deviation is 10 kilogram. Assuming the weights are normally distributed, find how many students weigh more than 75.5. Average weight is 65.5. But we need, out of the total of 500 students, how many students are expected to have a weight more than 75.5? And second question, between 55.5 and 75.5 kilogram. So two different questions are there. We'll attempt one by one. First, N, capital N is equal to total number of students. Capital N stands for total number of students, 500. Now mean, mu is equal to 65.5 kilograms, standard deviation is 10 kilogram. Standard normal variate formula, x minus mu by sigma, x minus 65.5 divided by 10. This formula will make use. Number of students having weight of more than 75.5. Pahla, first question. The first question is, how many students are expected to have a weight of more than 75.5? So when x is equal to 75.5, what is the value of z? So we substitute x is equal to 75.5, mu is 65.5, standard deviation 10. So we got 1. When x is equal to 75.5, we got the value of z as 1. Again we draw the normal curve. Center, mean, mu is equal to 65.5, z is equal to 0. Now x is 75.5. 75.5 is greater than 65.5. That's why I have taken on the right hand side. X is equal to 75.5, z is equal to 1. We need number of students having weight more than 75.5. It is not saying less than, it is more than 75.5. So right area, right side, this shaded area is our required area. हमको ये shaded area चाहिए जो 75.5 से ज़्यादा हो, right? Now area from z is equal to 0 to z is equal to 1. So if you refer the table, area table, 1 under 0. Z में जो है 1 से under 0 देखिए, you are going to get 0.3413. 0.3413 is the area from z is equal to 0 to z is equal to 1. तो under 1 के रो में देखेंगे under 0. Row 1 under 0 you will get 0.3413. So this unshaded area we got 0.3413. But we don't require this unshaded area. We want the shaded area. total area from the middle to the complete right is 0.5. So 0.5 minus 0.3413, you are going to get 0.1587. So shaded area आ गया 0.1587. Area for x greater than 75.5 is 0.5 minus 0.3413, 0.1587. Now we need how many students are expected to have a weight of more than 75. The number of students having a weight of more than 75.5 kilogram is 0.1587 into total number of students are 500. 79 students. Out of the total 500 students, we can expect 79 students will have a weight of more than 75.5 kilogram. That's it. First question completed. Now second question. Number of students having weight between 55.5 kilogram and 75.5 kilogram. अब दोनों के बीच में होना है 55.5 से लेकर 75.5 के बीच में कितने स्टूडेंट्स एक्सपेक्टेड है exactly similar to the previous problem. When x is equal to 55.5, z is equal to x minus mu by sigma 55.5 minus 65.5 mu divide by 10 minus 1. Z value is minus 1. When it is minus 1? When x. So when number of students having weight between 55.5 kilogram and 75.5 kilogram. When x is equal to 55.5, z value is minus 1. When x is equal to 75.5, z value is 75.5 minus 65.5 divided by 10, 1. Now we'll draw the normal curve to get the complete correct clear picture. So middle value 65.5, z is equal to 0. Now x is equal to 55.5. 55.5 is less than 65.5 to our left hand side. 75.5 is greater than 65.5, so I am taking on the right side. Right? So when 55.5 is there, z value is minus 1. 75.5, z value is plus 1. So we need this shaded area between 55.5 to 75. Now area from z is equal to 0 to z is equal to 1 is 0.3413. Z चाहे प्लस हो या माइनस हो, एरिया तो बराबर पॉजिटिव ही रहेगा. So from z is equal to 0 to z is equal to 0.3413. Here also 0.3413. Therefore total area from x is equal to 55.5 to x is equal to 75.5. That is 0.3413 plus 0.3413. We are going to get 0.6826. The number of students whose height is between 50, whose weight, not height, whose weight is between 55.5 kilogram and 75.5 kilogram is 500 into 0.6826. It will be 341 students. So 341 students are expected out of a total of 500 students. They are having a weight between 55.5 kilogram to 75.5 kilogram. So this is the end of problem number 9.